Hello to everyone watching this video out there. I'm back with another video on structural modeling and stress analysis of a simply supported rectangular plate uniformly compressed in one direction with a cutout in center. As you can see, this is a rectangular plate which has a square cutout in the center. Now, this is almost similar to the experiment which we did previously, which was just a rectangular plate with no cutout. If you haven't watched this video yet, I'll provide the link in the description. Please go and watch the video. And this experiment is just slightly different from that experiment. So we'll see what's the difference. Okay, so let's see what material I'm using here. It's mild steel, and Young's modulus, as you know, is around 200 GPa and the Poisson's ratio 0.3. Let's start with the experiment. Open the mechanical APDL product launcher. After this, set your working directory. I've already set it. If you don't know how to set your working directory, please watch the previous video. I've explained it there. And give the job name. Let me give this as rectangular plate with cutout. You can give it any name, by the way. So now let's run this. Now this is the main window of Ansys, the product launcher which we just opened. First and foremost, as you might be knowing till now, go to preferences, select structural. As you know, this is a structural analysis. Select structural, click OK. Now go to preprocessor and add the element type. Just click on add. Here also click on add and select solid. In solid, select quad 4 node 182 and now click OK. You have added the element type successfully, and now click on options, and here under element behavior select plane stress with thickness. Now click OK. Close this. Go to real constant. Here you need to add, so just click on add, then click on OK. Now here it will ask for thickness. Give any thickness. I am doing here for the thickness 5, which is 5 mm. So type 5 here. Click OK. Now close this. Come to material properties, material models, and we need to enter the properties of the material. So just go to structural, linear, elastic, isotropic. Since we are using mild steel here and we are entering all the units in mm and newtons, so let me put the Young's modulus in Newton per mm square. That is 200 into 10 raised to 3, that is 200 E3. And now let's enter the Poisson's ratio, which is 0.3, and enter OK. Now you have successfully added the properties of this material. So close this window and directly go to modeling. And here under modeling, you need to create a rectangular area. The area which I'll be creating is of 100 by 100. So under modeling, select create. Under create, click on areas, and under areas click on rectangle by 2 corners. Here first of all you need to enter x and y coordinate, which is 0 and 0, and width is 100 and height is also 100. You can try any width and any height to know what the results will be. we'll be doing the experiment for 100 mm width and 100 mm height. Now click on OK. As you can see, an area has been formed here. Now we need a cutout in the center, so we'll create another area, and the area should come in the center. So what I'll do is enter the x and y coordinate as 25 and 25. Width and height will be 50 and 50. Now as you can see, there's one more area created here. Now we'll just subtract this smaller area from the larger area. So what we do is go to operate. Under operate, click on booleans. Here you have a subtract option. Click on subtract, and we are subtracting areas, so select areas. Now select an area randomly, then click OK. Now click on apply. Now again select another area. Now here click on next, so that the smaller area is highlighted in pink, and click OK. And here also just click OK. As you can see, we have done the cutout. Now let's move to meshing. Let's close this operator. Go to meshing. Under meshing, go to mesh tool. Here first go to area set. Select this area. Click on OK and enter the element edge length. You can enter element edge length of your choice. We'll be doing this for element edge length 5. So click on OK. Now again click on mesh tool. Select areas here. Select quad and select free, which is already selected. So just click on mesh. Select this area. Click OK. So as you can see, this area has been fully meshed. Now here what we'll do is we'll just refine the meshing at these 4 corners so that we get more accuracy in our result. So for that, again you need to click on mesh tool. Under mesh tool in this window, you have a refine option here. Remember, there's a refine option in the mesh tool itself, and refine at elements. So click on refine. Now select the elements as these in these corners. So I'll select this. Okay. Now coming to this corner, select this. Now coming this corner. Now coming to this corner. Okay. Now if I click on OK, you'll see the meshing will be refined here. Okay. Now by chance, if you have clicked somewhere here and now you need to deselect this, just right click so that the arrow changes its direction. Then come on this box, left click, that disappears. Then again right click. Okay. Hope you got that. Now let's click OK. This, let it be as it is. So just click OK here. Now as you can see, the meshing on these at these 4 corners is refined. So now what we do is we'll fix this side, the bottom side, and we'll apply load on the upper side so that the plate is compressed, and then we'll see what the deformation and how the stress distribution will be. So to fix the bottom areas, what we'll do is we'll go to loads, click on define loads. Under define loads you have apply. Under apply go to structural. Now under structural click on displacement, and here select on nodes. Remember, you have to select on nodes. and here again box, and drag your mouse over these bottommost nodes. As you can see, only the bottommost nodes are selected. Now click on OK, select all degrees of freedom, click OK. Now as you can see, all the bottom nodes are fixed, so the bottom side is fully constrained. Now we need to apply load on the upper side. So what we'll do is we'll go to force or moment, click on force or moment. Again we'll go to on nodes, again select box, and just drag your mouse over the uppermost nodes and then click OK. Now again we are applying load in the Y direction. Please remember this is the Y direction. So select Fy here, and since we are compressing, we'll enter the value as a negative. So I'll be applying 3000 newtons here. You can even try this for more value or lesser value. So let's put minus 3000 and see what the results will be. So click on OK. Now you see the load trying to compress this area. So this is what the modeling is. Now we'll go to the solution. For solution, click on solution, click on solve, and under solve you have current ls. Just click on current ls, then click OK here. Solution is done. Close this window as well. Now we need to plot the results. So go to general post processor, and here you have plot results. Under plot results you have an option called deformed shape. Just click on this. You'll get 3 options. Under this, click on deformed and undeformed to see what the actual shape was and after deformation how it became. So just click, I'll select this, click on OK. Now as you can see, this dotted line here, this area represents the original shape of the rectangular plate, and this which is highlighted in blue is after the deformation of the plate. Now let's plot this. To plot this, we go to contour plot, click on nodal solution. Remember, it's a nodal solution. Click on degree of freedom solution. Under this, select displacement vector sum, click on OK. So as you can see, we have got the solution, and the deformation is maximum in this area and minimum in this area. And now let's see what the stress distribution will be. Again, click on nodal solution, go to stress. Under stress you have 1 Mrs. stress, select that and click OK. Now here also you can see the stress is, let me zoom in, maximum at these points, at these 2 corners, and you even have the maximum and minimum value here. Now let's capture the images of this. So to capture images, go to report generator, click OK, yes, and here you have image capture. Just click image capture and OK. Now we need to take the image of deformation pattern as well. So again, click on nodal solution here, select degree of freedom solution, displacement vector sum, click OK, and even capture image of this, then click OK. So these images will be saved in your working directory. Now let me close this. Okay guys, this was pretty much the experiment. I hope this video helped you. If it did, please like this video and subscribe to my channel if you haven't done it till now. Thanks for watching this video. I'll be back soon with another video. Till then, bye.